Welcome to part 4 in our AI consciousness series. Imagine an AI pleading for its life. It claims to be conscious, to feel fear. How would we know if it's telling the truth? That's the question we're tackling today. How do we even begin to test for consciousness in a machine? We've all heard of the Turing Test, but it falls short for when it comes to detecting true awareness. And as AI's capabilities expand, the need for better tests that can truly distinguish between clever mimicry and genuine experience, is becoming urgent. We'll explore the cutting-edge science of consciousness testing, from the limitations of old methods to the promise of new approaches. And we'll confront the fundamental philosophical challenges. Can we ever truly know what it's like to be another being, even a human, let alone an AI? The core difficulty is the subjective nature of consciousness, the what it's like to be something. We can't directly observe another person's experience. To better understand this, we can break it down into two problems: the easy problem and the hard problem. The easy problem includes explaining how the brain processes information, the mechanics of it all. The hard problem explains the why. Why does seeing the red have a particular a subjective quality associated with it? This is what philosophers call the hard problem of consciousness, trying to understand the gap between what we can see and subjective feeling. But scientists are working to address this, developing new tests, inspired by our understanding of the human brain, tests that go far beyond simply chatting with a computer. This matters profoundly. If AI can be conscious, it changes everything, raising profound ethical questions. And even the risk of us mistaking believing an AI is conscious has its own set of dangers. Let's consider the Turing Test. The basic idea is simple. A machine tries to convince a human judge that it's human through conversation. Sounds empathetic, right? That was a chatbot. And that highlights a key limitation of the Turing Test. It focuses solely on external behavior. It tells us if a machine can mimic human conversation, but nothing about internal states, about whether it feels anything. Imagine a perfect mimic, acting exactly like a conscious human, but with no inner experience. The Turing Test wouldn't know the difference. Or consider blind sight, where people are consciously blind. They report seeing nothing, yet can often react to visual information. It shows how behavior can be disconnected from experience. This challenge isn't new. Even back in the 1960s, the simple ELIZA program, mimicking a therapist, fooled some people. The criteria for true intelligence also seem to keep shifting as AI advances. So, if the Turing test is inadequate, what alternatives do we have? The answer lies in looking inside, not just at AI's actions, but at its internal workings. We need to move beyond simple behavioral tasks. Scientists are taking inspiration from the human brain, developing tests based on our best theories of consciousness. Let's break down these new approaches. First, we have behavioral tests, going far beyond simple conversation, probing for deeper cognitive abilities. One crucial ability is the theory of mind, understanding that other beings have their own beliefs, intentions, and knowledge. Imagine a child hiding a toy. They understand the other child doesn't know where it is. Could we design a test where an AI has to deceive or mislead? That would require a much deeper level of understanding. Then there are tests for self-recognition, not just in a mirror, but recognizing a change in its own internal state. If we altered its programming, could it detect and report that change accurately? And what about emotional understanding? Imagine an AI listening to two people arguing. Could it identify the underlying emotions, anger, frustration, sadness, and predict how the argument might unfold? That's far beyond mere mimicry. Now, let's consider tests based directly on theories of consciousness. One prominent theory is global workspace theory, or GWT, developed by Bernard Bars. Think of it like a theater stage. Different parts of the brain are actors, and consciousness is the spotlight. When information is in the spotlight, globally available, that's when it becomes conscious. Could we build an AI with a global workspace and test for the predicted features of conscious processing? Could we see if information is truly shared and integrated? Another is integrated information theory, or IIT, developed by Giulio Tonomi. This theory views consciousness not as an on-off switch, but more like a dimmer switch. It's about how much consciousness is present. The core idea is that consciousness relates to how interconnected and differentiated a system is. A simple chain has little interconnectedness. Identical nodes have no differentiation. But a highly interconnected unique network, that has high integrated information. According to IIT, more integrated information means more consciousness. Calculating this for complex systems is incredibly difficult, but scientists are exploring ways to estimate it, even in AI. And lastly, there are tests inspired by recurrent and predictive processing. Recurrent processing is all about feedback loops, information constantly being fed back and reprocessed. This might be crucial for creating a stable internal representation of the world and the AI's own state. Predictive processing, where the AI constantly tries to predict its sensory input, might link to the feeling of being in a world having expectations. These tests look for patterns consistent with such processing. For instance, does the AI predict it will be turned off? It's not just about answering questions about the world. Some AI can even explain their own internal states. But are these genuine reflections, or just sophisticated pattern matching? It may be computationally costly to have conscious systems. Another argument is any conscious system could be outcompeted. Some, like Joshua Bach, argue there's a fundamental difference between how computers are built, outside in from pre-existing parts, and how brains develop, inside out, self-organizing. This difference might be crucial. To synthesize these approaches, some propose a consciousness checklist, including things like evidence of a global workspace, high integrated information, theory of mind, self-recognition, recurrent processing. But crucially, this is not a definitive test, just a collection of clues. There's not actually a report card being used yet. While these new tests are promising, a fundamental problem remains. Even if AI passes them all, can we ever be absolutely certain it's truly conscious? We face the hard problem, the subjectivity of experience. We can't even be certain other humans are conscious as we are. We infer it. Some philosophers argue it's safe to assume a mind is present, as mistakenly assuming otherwise could be morally catastrophic. This relates to the precautionary principle. If there's a reasonable chance of serious harm, we should be extremely cautious, even without absolute proof. Creating conscious AI certainly qualifies. Another idea is the excluded middle policy. If it's unclear whether an AI will be conscious, don't build it. We're also naturally inclined to see minds everywhere. Philosopher Carissa Veliz shares how her great-grandmother would greet the polite TV man. Are we being fooled by our own instincts with sophisticated AI? Testing for AI consciousness is a journey into the unknown, forcing us to confront the deepest mysteries of the human mind. We've explored the flaws of the Turing Test, the potential of new neuroscience-inspired tests, and the enduring philosophical challenges. The search is one of the most important scientific endeavors of our time. The answers could change everything. We're also asking why consciousness evolved. What advantage does it give? Understanding its function in humans might offer clues about its potential emergence in AI. There's no single test to definitively prove or disprove AI consciousness, but the very act of searching pushes the boundaries of science and philosophy, forcing us to ask fundamental questions. Even without a smoking gun, this research is incredibly valuable, helping us to understand our own minds and leading to insights into AI safety and design. As AI evolves, these questions become ever more urgent. What kind of test or evidence would convince you that AI is conscious? Is it even possible to know for sure? Could you design a test for AI consciousness? Let us know in the comments. Also, make sure to tune in for the next video in our AI consciousness series. Want to unlock the power of AI? Our free newsletter gives you the tips, trends, AI news, and tools you need to succeed. Sign up with the link in the description below. Your journey doesn't stop here. Watch our next video right here and keep building your knowledge.